Hi everyone, welcome back to the discussion of weekly Leetcode Contest 381. So, in this particular lecture, let's cover the second and fourth problem that was there in this contest. The fourth one being a little harder problem, harder variation of the same problem as the second one, right? So, we'll go over the brute force, optimize, and so on and so forth, and finally come up with an optimal solution out of it. So, let's start. So, let's go to the problem first. So, the problem states that we are given three positive integers, right? So it is just says that we are given three numbers, n, x and y, right? Now it goes on and says that let's say there are n houses connected, like one house connected with two, connected with three, connected with four, so on and so forth up to n. So connected in a straight line essentially. Apart from that, xth house is also connected directly with the yth house. So if you look at it here, xth house, which is this one, is directly connected to the yth house, which is this 3. Let's look at some other case as well. So n is 5. So we have 5 houses connected with one another. House number 2 is also connected with house number 4. So that is what the scenario is. So n houses given in a line, right? And then apart from that, xth house is also directly connected to the yth house. Okay. Now what you need to do, you need to look at all the pairs of houses and find their shortest distance. So if I take n houses, then essentially distance from 1 to 2, 1 to 3, 1 to 4. Similarly from 2 to 1, 2 to 3, 2 to 4, so on and so forth. So n into n minus 1 total combinations of pairs you need to look at, find their shortest distances, and then what do we do with that? So we need to give a result array of size n or size k, having that, okay, these many pairs are at distance 1, these many pairs are at distance 2, so on and so forth. So for example, if I take this case out, if I look at distance 1, so we have 1, 2 at distance 1. We also have 2, 3 at distance 1. We have 1, 3 at distance 1. And similarly the opposite way around. So 2, 1, 3, 2 and 3, 1 as well. So 6 pairs having distance 1 and no pairs having distance 2 or 3 in this particular scenario. Let's look at the second case. So again we have 1, 2, 2, 3, 3, 4, 4, 5. So 4 pairs having distance 1. Apart from that, 2, 4 also having distance 1. So 5 pairs having distance 1. So we have 10. Similarly, if we look at two distances, so 1 and 3 have 2 distance. Similarly, if I talk about 1, 4 as well, so 1 to 2, 2 to 4, that also has 2 distance. Similarly, 5, 4, 5, 3, they both have 2 distance, right? So that is the pairs that you can see. So 1, 3, 3, 1, so 1, 3 and 3, 1, 1, 4 and 4, 1, so 1, 4 because 1, 2, 4 and 4, 2, 1, so 1, 4 and 4, 1. Similarly 2, 5, 5, 2 and 3, 5, 5, 3. So from 5 if I want to reach 2 also, so 5, 4, 2 or 2, 4, 5, so that is why 2, 5 and 5, 2. Similarly 3, 5, 5, 3 because it is very much possible that I reach from 3 to 5 as well, right? So 3 is here, 5 is here, so yeah, we can easily reach as well. Cool. So this is essentially what the question asks you to say. Find an array equal to distance, like equal to the total number of elements, which is n, and at array of I you have number of pairs having shortest distance I between them. Cool. So just pause the video here and think about some brute force idea how we can go about doing it. Okay, so let's probably go to our whiteboard. So first of all, we know that if we do not even go into some details, we know that what we are given is essentially a straight line of few houses and 2 of them are also connected. So this is nothing but something like a graph. There are some special properties of this graph that I agree with, but at the end of the day, it is still a graph. And what kind of graph? It is an undirected graph, first of all. Like if you think about it, 1 to 2 is connected, so 2 to 1 is also connected. Last, it is unweighted graph, like every distance is taken as 1. So it is in fact a unweighted graph, right? So in undirected unweighted graph, if I want to find shortest distance from one node to every other node, then we already know that BFS works. Breadth first search works. I've talked about it in one of the previous videos as well, but the simple idea being, let's say you are at a node, then the next connected nodes are at distance 1. Then the next connected nodes are at distance 2. And that is the order of visiting in BFS. From any node, you first visit the just connected nodes, then the next, so on and so forth. So something like a level order. Cool. So what we can simply think of as a brute force is, from every node, we'll run a BFS algorithm. So from 1 we'll run a BFS, from 2 we'll run a BFS, from 3 we'll run a BFS, right? So from every node we will run a BFS algorithm to find out distance of every other node from this particular node, right? So from distance of every node from 1, distance of every node from 2, so on and so forth. So once I have that, now I kind of already know the distance between every pair, right? And I can simply use that to fill up my array that I wanted to calculate. So for example, if distance array of first node says that, okay, node number 2 is at distance 1, node number 3 is at distance 2, node number 4 is, let's say, again at distance 1, so on and so forth. So I can use this now to count how many are at distance 1, how many are at distance 2, so on and so forth. So just do count of distance of ij plus plus, right? So simply doing this would increase the count at that particular distance, and finally we'll get our solution in that count array. Okay. So with this idea, we can in fact do it, but if we think about the time complexity of this, then from every node, that is from every of the n nodes, you are essentially running a breadth first search, which takes up n time. So this solution would in fact be n square in nature, because from every node you are running a BFS and going to every other node, which is n square. Similarly, the last part where you're going over the entire matrix of distances and doing count of distance plus plus, that also requires you to do n square steps. So both the steps here are actually n square. And yeah, so if we look at the constraints of the problem, for the first part of the question, which said that n is just 100, this would in fact pass, right? That should not be an issue at all for n equal to 100. So let me just change the screen. Yeah. So the first part of the question says n is just 100. So 100 into 100 is 10 to the power 4, which should very well pass. But the last part, it says n is 10 to the power 5. So with n 10 to the power 5, this solution would obviously not pass, and we would need to optimize. Okay, cool. So generally in such a question where you have used incomplete information to come up with brute force, the way to improve lies on the parts that you have left off. So for example, here in this question, we did not take the scenario into consideration that, okay, generally it's a straight line. It's not a proper graph. It's a straight line and two other nodes are coming as a connection, right? Just two nodes, X and Y, they are coming as a connection. So in fact, the kind of graphs that we are looking at are very, very special. But our solution generally works with a generic graph, right? So whenever you want to optimize such kind of questions, the optimization occurs through incorporating these special constraints into our question. So let's try to do that now. Okay. So let's say our graph is such that it has some nodes connected in a straight line. Let's take 7. Let's forget about the X and Y connection and try to calculate the answer for such a scenario. Just pause the video for a moment here and try to think, can we directly generate the output for a straight line without modeling it as a graph? So great if you were able to think so. So the answer for this is relatively simple. If I want to know distance 1, then if there are n nodes connected, n minus 1 of them, n minus 1 pairs will exist, like 1 2 2 3 3 4 4 5 up to 6 7. So, or n minus 1 and n. So if you think about it, there are n minus 1 pairs like this that would occur, which will be at distance 1. So n minus 1. But remember, it's an undirected graph. So if 1 2 is an answer, so 2 1 is also an answer. So whatever in the end we get, we need to multiply it with 2. So actually the number of pairs is 2 into n minus 1. But for now, we are just using n minus 1 and we'll multiply by 2 later, right? Because it's an undirected. So even if we calculate from one side, the other side can just be calculated by multiplying by 2. Okay. Now let's look at distance 2. So if I want distance 2 from 1, I'll go to 3. Distance 2 from 2, I'll go to 4. So on and so forth. So if you think about it, there were n nodes. 1 1 connection, we had n minus 1 connections. 2 2 connections, we'll have n minus 2 connections. You can even try to do it mathematically or by observation on copy pen. But you will clearly see that since we are skipping an element and going over, so the last two elements that are there, 6 and 7, they would not have a pair. Rest everyone would have a pair at 2 steps ahead. So that means out of n, n minus 2 have a pair with them. So the answer would be n minus 2 here. Similarly for distance 3, last 3 would not have a pair. So n minus 3. Right? So similarly we can populate this array. So if it's a straight line, our answer is simple. Let's go from 1 till n, and the answer is n minus I, whatever we are using for iteration. Okay. So now that we have this out of picture, let's try to incorporate our XY connection. So let's say some random 2 nodes are also connected. So let's take that. So we have 1, 2, 3, 4, 5, 6 and 7. Let's take any 2 nodes, let's say 3 and 6, and they get connected. Okay. So now when this happens, what clearly will end up happening is a cycle would be formed. And not n number of cycles, just one and only one cycle would be formed. So our graph would be like, there is a cycle and there would be some nodes connected to one node of the cycle and some other nodes connected to another node of the cycle, right? And these are nothing but our x and y nodes which have been connected to form the cycle. So imagine straight line and 2 nodes get connected. So that is the kind of graph that we are dealing with in this particular question. Okay. So now let's try to think what will change in our answer, or how will we calculate answer in this specific scenario, right? Okay. So if I think about it, what we have done essentially when we are dealing with this kind of a graph is that we have divided our graph into 3 parts. 1, the cycle, and the tail, which is the third part. So I'll call this head, call this the cycle, and call this the tail. Now there might be the case that head is not there at all, or might be the case that tail is not there at all. Those kind of scenarios are possible, but in generic scenario, these 3 are the parts of the graph that are there. Okay. So now if we think about it, any node from our head or tail, if we try to connect them, if we try to find the shortest distance between any node in head to any node in tail, then it would in fact look something like this. We'll go from 2 to 3, which is the start of the cycle, from 3 to 6 directly, and from there we'll go to the tail, right? So any node, any pair of nodes where one node is in head, another node is in tail, their distance would always be like this, right? If I talk about head head, like if both nodes are in head, then it would be same as straight line. Similarly, tail tail would be same as kind of like our straight line. So can I say to incorporate the nodes only in head and tail, only these nodes and the connections between them, what I can imagine is a straight line having the head nodes x, y and our tail. So essentially nothing but 1, 2, start of the cycle which is 3, then 6 and 7. Why? Because to reach from any of this node now to any of the other node, this is the path that we'll follow. We'll not try to go via 4, 5. That doesn't make sense, because we have found a shorter path directly from x to y, right? So if I calculate the result of this, I will in fact get all the pairs where one node is in head or tail, or the x and y, and the other node is also in head or tail or x and y, right? So these cases would actually be solved via this particular consideration of a straight line having the head nodes, head nodes, the tail nodes and the middle two nodes of cycle. Okay, so we have handled one case which is from head to tail. Let's talk about the next case where we are dealing with head or tail to cycle. So we need to also incorporate head. So there are three cases essentially: from head tail nodes to head tail nodes directly, from head tail nodes to cycle nodes, and third would be from cycle nodes to cycle node itself, right? So three cases. We've handled first case where we are dealing with head tail nodes to head tail nodes directly. So let's talk about the second case where we are dealing with, we want to reach from these head tail nodes to the cycle nodes. So we have 1, 2 which are our head nodes, we have the cycle, and we have the 7 which is the tail node. Okay, so in this particular scenario, if you think about it, to reach any node in the cycle, we have two options. So for example, to reach this 5, let's say from this 2, what I can do, one option is I go to x, like if I'm dealing with head, I go to x, then from this x I directly traverse to 5, so I'll go 3 to 4, 4 to 5. Second way is from this head I directly jump to tail, and from there I go back. So let's take another example. Let's say instead of 3, 4, 5 there was 6, 7. Let's say 7 was also part of the cycle. Let me use an eraser. Right, so let's take this out. So let's say 7 is also here, and finally we had the 8 here. So now to actually go from 2 to 6, better way would have been from 2 to 3, we go from 3 to 7 and 7 to 6. So ideally for every node we should calculate two values. If I am coming from head, what is the distance? So if I'm coming from head, what is the distance? So if I'm coming from head, either from 3 I can directly go to 6, so 1, 2, 3, or I can go from 3 to 7 and travel back from 7, so 1 and 2, so minimum of these two. Similarly, if I'm traveling from tail, again there are two ways. Either I can go from tail to 7, 7 to 6, so 2, or tail to 7, 7 to 3, and then travel back to 6, so 1, 2, 3, 4, 5. So for every node, if we have these two values, two values, that if I'm traveling from head, what is the distance that I need to cover in the cycle, and if I'm traveling from tail, then what is the distance that I need to cover in cycle, then I can in fact get my answer by iterating on these head nodes and tail nodes and calculating the corresponding values. So yeah, this is the second case on how to handle it. For every node we would store what is the minimum distance that we need to travel in the cycle to reach from the head, what is the minimum distance we need to travel to reach this node in the cycle from the end of the tail, right? And if we have that, then using these distances we can compute our answer. So last case, by the way, I'll go into detail of the implementation of each concept by looking at the code. Right now I'm just trying to brief the three ideas, right? How did we go about solutioning this problem, right? I know it's a very tough problem, considering it had 3 to 4 sub problems inside it, right? But yeah, just bear with me for some more time. So last part was dealing with the cycle nodes directly. Okay, so just the cycle nodes with itself, right? So let's take 3, 4, 5, 6, 7 here. Okay, so if I try to find how many node pairs are at distance 1, so 3 to 4 is at distance 1, 4 to 5, 5 to 6, 6 to 7, 7 to 3. So if there are 5 nodes in the cycle, each of them have a distance 1 node. Similarly, if there are 5 nodes in the cycle, each of them have distance 2 nodes also. So 3 to 5, 4 to 6, 5 to 7, then 6 to 3, then finally 7 to 4. So they all have 2 distance nodes as well. But as soon as I go to 3 distance, 3 to 6, sorry, 3 to 6, then in fact, instead of 3 to 6, they would have already been counted in 6 to 3 way back, like that has distance 2, which is lesser, right? So yeah, basically for every node less than half of the cycle length, each of them would have a pair corresponding to them, right? So for distance less than length by 2, my answer would always be equal to the number of nodes in the cycle. Okay, but let's take a scenario of even length as well. I've talked about less than length by 2, but what if it's equal to length by 2? So let's also take an example of even length cycles. So let's take 4 elements, 1, 2, 3, 4. So let's take distance 1. Answer is 4 because 1 has distance 1, 2, 2 has 3, 3 has 4, 4 has 1. So distance 4 is fine. But if I talk about distance equal to 2, each one has a node at distance 2, but their pair doesn't exist. So if I talk about it, 1 has 3, but 3 also has 1. So they are going to be the same. So multiplying by 2 later would increase the result even further. So in this particular scenario, when we are dealing with equal to length by 2, each will not have a pair, but only half of them will have the pair. So in this case, the answer will be 2. Similarly, if we take 6 length cycle, for distance 1 and distance 2, all 6 will have their pairs. Even if I look at distance 2, this will have its pair as this will have its pair as this will have its pair as this, so on and so forth, right? So each will have a distance 2 element. But for distance 3, which is exactly equal to the cycle length by 2, the pairs will cancel out. So 1 will have 3 and 3 will also have 1. So only half of them will have unique pairs corresponding to them. So this is a special scenario. We need to go up to length by 2, but if it's exactly length by 2, then only half of them will have pair. For rest, all of them will have a corresponding pair. So yeah, these are the 3 particular scenarios that we need to handle in our code. So let's quickly jump on and look at the code as well. Okay, so here is the code. So if we look at the overall what we have done here, so first thing that I've done is if x is greater than y, then I've swapped x and y. So I've tried to keep x as the smaller node of the cycle and y as the greater node of the cycle, right? So if it's the other way around, we have swapped it. Next, I've checked if x is equal to y. So if we are trying to connect the same node with itself, then this loop would be useless. We would just have a straight line. So what I've done, I've created a vector of my result. I've just handle across. So handle across is the function that deals with a straight line. So I've said it's a straight line of n, and just update this result distance array. Then multiply does into 2. So it would multiply each of the distances by 2 because that is what we needed to do at the end, and then it returns the result. Okay, so this is for x equal to y, that is if it's a same loop cycle. We'll look at the handle across function in a moment, and multiply function as well. Multiply, even in fact you can see it here as well. So it does nothing but it just goes over the entire distance and multiply each of them with 2. Let's also look at the handle across, which is straight line code. So if you remember, what did I say? I said that we'll iterate from 1 till length of the straight line, and for each of them we would add length minus I to the answer. So that is what I've done. So for length 1 it would be n minus 1, length minus 1. For length 2, for distance 2 it would be length minus 2. For distance 3 it would be length minus 3, so on and so forth. So that is what I've done here. I've used I minus 1 because the question wanted the result of distance 1 at position 0, distance 2 at position 1, so on and so forth. So that is why this I minus 1 is there everywhere. Okay, so this is handle across, which handles straight line. This is our multiply, which multiplies by 2. Okay, so we have handled the x equal to y case. Otherwise, what we need to do, I have said that there is a straight line of n minus y minus x minus 1 distance. So if you think about it, what has happened? From total n, we have removed the cycle, and not everything from the cycle, we have kept x and y. So what is the length of the cycle? Y minus x. Y minus x would give me, in a way, the total number of nodes that are there in the cycle, right? Actually, not y minus x, but it would have been, because x then would not be included. So y minus x minus 1 would actually give me the total number of nodes in the cycle. But out of that, I need to include x and y in the result. So that is what I have done is I have written y minus x minus 1. That okay, from y minus x you have removed x already, but also remove y, so that is y minus 1. Okay, so this is the straight line, and update the result. So if I talk about it, which case we are handling in this particular scenario, then I'll say this is the case of this one, where we said that we would remove the cycle and we'll just take 1, 2, 3, 6 and 7 in a straight line and find the result for them to handle head to tail nodes, right? So this is the first case which handle the nodes which are from head tail to head tail itself. Let's go back. So this is the first, which handle across. Then I've written, let's handle the circle or the cycle that we have of length y minus x plus 1. So I already told y minus x would exclude x also. So y minus x plus 1, that is the total length of this circle that we are dealing with. Okay. Now the problem with this would be that even in the straight line and even in the circle, we have included x and y itself, like so distance between x and y, they would have been included even in the straight line and even in the circle. So what I've done, I've written this handle duplicate, which is just nothing but, since x and y have a distance of 1 between them, it just does minus minus on that 0th position. So let's just look at the two cases, two functions, handle circle and handle duplicate as well. So handle circle, as I said, will go up to length by 2. If it's exactly equal to length by 2, then I'll add half, because half of them will have pair. Otherwise, to that distance I'll add the entire length, right? Because all of them will have a node at that particular distance add from them, right? So for example, if we are dealing with first node of the cycle, then at distance 2 also there will be a pair node, right? So even with second node, there will be a pair node at distance 2, so on and so forth. So yeah, this is the handle circle function. Handle duplicate does nothing but just reduces the extra duplicate that we got for xy, because xy was included both in the straight line, like when we did 1, 2, 3 and 6, 7. So 3 and 6 are there in the straight line, and similarly when we take cycle 3, 4, 5, 6, so 3 and 6 are there even in the cycle. So to handle that duplicate, we have reduced minus minus for that. Last function is handle mix. Handle mix, what it does, it tries to look at the distances of nodes from outside the cycle to inside the cycle. and finally I've done the multiply by 2, which is again the same. So let's look at the last function, handle mix, which is the most complicated one. So first what I did, I tried to calculate for each node what is the distance of them from x and what is the distance from them from y, because that is what I talked about, right? So distance from x will tell me that okay, if there are some nodes in the head part of my graph, then what is the extra distance that they would need to travel in the cycle. Distance y tells me the tail nodes, what is the extra distance that they need to travel from y to reach this particular node. So we have distance x, distance y. So what I've done, for every node from x plus 1 to y, so every node in the cycle, I've tried to calculate their distance from x and distance from y plus 1, because if I want to calculate distance from x, either they can directly go from x. So if node number is x plus 5, then x plus 5 minus x would give me the number of steps, or from x I can go to y and then travel back. So y minus I to travel back and plus 1 to go from x to y. So yeah, this similarly from y. So either from y you can directly go back, or from y you can go to x and then travel forward, right? So the two examples. So that is how I have updated the distance y and distance x. Okay. Now, next thing that I've done, I've tried to calculate how many nodes are there in the left, because for all of these nodes, right, for example, if the nodes are at distance 1, 2 and 3, then 1 plus distance, 2 plus distance, 3 plus distance, all of them will get plus 1 values, right? So that is what I've done. So yeah, so number of nodes left are x minus 1, right? So I have used the approach of plus 1 minus 1. Like for example, if you want to increase all the values by 1 in L to R, so what you do R plus plus L minus 1, L plus plus R plus 1 minus minus, and then you try to take the prefix sum. So I'll probably mention this approach quickly, the last part. This is again a common pattern. So if there is an array having all zeros, and let's say what we want to do, we want to increase L to R, all values by plus 1 or plus 5 for that matter. So what do? I go to R. So let's say R is 3. So I'll go to 3, 0, 1, 2, 3 and do, so like let's say L is 1. So I'll go to first L, increase it by 5. I go to R plus 1, decrease it by 5. Similarly, let's say there are some more. So let's say from 2 to 4, I want to increase by 4. So what I'll do, I'll go again to 2, increase it by 4. I'll go to 4 plus 1, which is 5. So 0, 1, 2, 3, 4, 5. So here, and I'll do minus 4. So what will this help us doing is, it will let us do a prefix sum now and actually add that value in all the nodes till we cancel it out by minus 5. So if you do prefix sum of this array, then at the end you will end up getting the pluses at the right position. This is actually a very famous technique of utilizing prefix sum to range update L to R values, right? So that is what I've done here. So now that I knew that, okay, let's say there are 3 nodes on the head part. Okay, so there are 3 nodes in the head part, and let's say there is a node in the cycle which is at distance 2 from the starting. So what I would need to do, I would need to add 1 to 2 plus 1, 2 plus 1. I would need to add 1 to 2 plus 2, 2 plus 2 for this particular node, and 2 plus 3. So in a way, it's a range update of plus 1 in the range of 2 plus 1 to 2 plus 3. So that is what I've done here. If you look at the code, I know the number of nodes on the head part, which are node on the left side. So what I've done, I've said that I would do distance of I plus 1 I would add, and in I plus 1 node plus node left I would subtract. So kind of like finding the range that okay, from I plus 1, like whatever is the distance as of now, like yeah, if distance from the start is let's say 2, then 2 plus 1 2 plus number of nodes left plus 1, in that range I need to update the value, right? So that is what I've done here. Okay, so by the way, this I is nothing but your distance that you are iterating on. So earlier what you did, you tried to calculate that okay, in distance x, what are the distances of different like what are the different distances available, right? For example, there are 2 nodes at distance 2 from x, there are 3 nodes at distance 3 from x, so on and so forth, right? So you are using that information to update your distance temp. Okay, so just go over this code once and you'll be able to realize what it is trying to do. Similarly, I'm doing for the right side. Finally, I just take the prefix sum. So this is the prefix sum part, and update my distances. So this is the handle mix part, where what you are doing for every node, you calculate the distance from the starting of the cycle, from the ending of the cycle. Now, for all the nodes in the head, you update the corresponding values in the distance array, and for all the nodes in the tail, you update the distance in the corresponding array. Cool then. So I'll attach this code to the solution. Do check it out, right? As I said, it was a relatively tougher problem. But yeah, the main challenging thing here was to divide it into smaller parts and then to solve each part individually. That is also how I structured the solution during the contest, right? So I was able to get the circle part very quickly, the straight line part very quickly, and the handle mix part was the major one which I spent more time on, and finally was able to get it around as well, right? Cool then. So yeah, this is how we can attempt this particular problem. More mathematical in nature, so I would not have any points to or patterns to take from this problem, apart from probably the range update one, right? Which is kind of like a known pattern if you have done prefix sum in detail. Okay then, see you guys next time. Just like the channel, like the video, subscribe to the channel, and make sure that you share it with your friends.